This video lesson is on ratios. You are expected to take notes. If you do not have your materials out, please pause the video and get them out now. If at any time during this video I am talking too fast or you don't understand an example on the first try, please pause the video and back it up so you have time to understand and write everything down. Let's talk about ratios. First, we have to decide and figure out what a ratio is. And the definition of a ratio is a comparison between two amounts, okay? It's a comparison of two different amounts. You're going to see a lot of writing on here, and I'm going to go over and talk to you about every little thing. So, if I want to talk about how many cats and dogs a person has, since I mentioned cats first, that's going to go on top. And I'm going to talk about a ratio of 4 to 1. This says 2 right here in the middle. Okay? This is not a fraction. This is just fraction form. We're going to find out two other ways to write a ratio, but we're going to focus mainly on fraction form. It's set up mathematically for us to work with it. Now, it looks similar to a fraction. It is not. That's really important to know. And what it says over here underneath, this little green point here, it says that you can simplify it, but not to a whole or a mixed number. Again, this says 4 to 1. Think about the definition of a ratio and then try to figure out for yourself why you can't write it as a whole number or a mixed number. Okay, so if I were to take this idea as a fraction and simplify it, this would clearly simplify dividing the top to the bottom to 4. How is 4 a comparison to anything? 4 is just one amount, and if you look in the definition of ratio, it clearly says it's two separate amounts. Okay, and if I had something, I'm going to use some space over here, like 5 cats to 2 dogs, which is my current household situation, certainly if I looked at it as a fraction and reduced it, 2.5, whoops, that's not a comparison. Again, that's one amount. 2.5 what? Okay, 3 different ways to write ratios. There's words, as you can see, 4 to 1. I spelled everything out. That's cool. You can use a colon between the two numbers, so that kind of looks like this with these two dots. And the little dots is where you would read the word 2, so you have 4 to 1. In fraction form, which is what we started with, again, the main one we're going to focus on, and this is where the little line kind of says the word 2. And that still reads 4 to 1. So they all read the same way. 4 to 1, 4 to 1, and 4 to 1. But they just look different. Now, that's a lot of information. It's a good idea to pause the video now, if you haven't already, to write all of this down. One idea we're going to talk about is equivalent ratios. And we all know the word equivalent, like it says up on top in parentheses. Equivalent means equal. So if in a classroom I had 7 girls and 4 boys, notice the one I mentioned first goes on top, just like anything else we've done. Excuse me. If I had a class of 7 girls with 4 boys, what if I doubled the amount of girls in that class? How many boys would I have? Oh, excuse me. Yep, I would have 8. So if I doubled the amount of girls, I would have to double the amount of boys to keep it proportionate. For every 7 girls, there's 4 boys. So if I have 7 more girls, there would be 4 more boys. So it's kind of doubling those amounts. And you're really familiar with that. We're going to use the idea of equivalent ratios excuse me, to make comparisons between ratios. We might also have to write ratios in simplest form. And again, that's just like reducing. If I had a ratio of maybe 8 girls to 6 boys, I could reduce that and say for every 4 girls, there's 3 boys. And now I just put the girls first, and that's okay. Ladies first is the polite way to go on that. Okay. One other way to start comparing, oh, no, we're going to look at an example first. So let's try this out. This is a little section of piano keys here, and this little square here says that there are 5 black piano keys and 7 white piano keys in a small section of that piano where there are, I'm only looking at 12 keys. Now, I do believe there's 88 keys on a piano, so this is just a small section. If we look at this first thing over here, I'm asking, what is the ratio of black piano keys to white piano keys? And I'm going to give you a couple options here so you can try it out. 7 to 5, 7 to 12, 5 to 7, 5 to 12. Wow, I could do so many things with this. 12 to 7 or 12 to 5. So all of those contain relationships between the number of 12 total piano keys, 7 white, and 5 black. So how do I write it? How do I choose? These are all legit ratios here. Well, what am I asking you for? Black keys. How many black keys are there? 5. So that eliminates a lot. Remember I said the first one goes on top? So that's not a choice. And these aren't choices. Look at that. That was pretty easy right there. So now, what is the second thing I'm asking for? The relationship from black keys to white keys, and there are only 7 of those. So 5 to 7 is the ratio I'm looking for here. Okay? Now I have some other questions over here, so I have to erase some of this stuff. I got a little carried away with examples. How about the next one says W to total. So I'm looking for the number of white piano keys to the total. So set that up. How many white keys? 7. The total amount of keys are 12. Okay. How about the number of black piano keys to total? Set that up. We already did black first as 5 and total is 12. Okay. What if I were to double the section of piano keys? Now I'm talking about a total of 24 piano keys. So, I erased my proper option, which was 5 to 7. So if I've doubled this, let's double each of these ratios to match the appropriate selection we have now. Because now we're not talking about 12 piano keys, we're talking about 24. And if the total number doubles, we've compared the amount, we could assume that the top numbers would double as well. And by top, I mean these little sections here. So rewrite all 3 of these as doubled ratios. If before I had 5 for every 7, it makes sense that if I had 10 for every 14, for every 12 I had 7, now I have 24, so I should have 14. I had 5 for every 12, so now I have 10 out of the 24. So that's writing equivalent ratios. It feels the same as what we do with fractions. And so we're going to take a moment and look about comparing ratios to fractions. Now I set up like a little grid here because they are similar, and so we want to separate some of our ideas of ratios to fractions. How they are the same, look at this hot mess. They look the same as a number over a number, just like we had 10 over 14 here, 10 to 14, 10 black keys to 14 white piano keys as well. You can reduce with the greatest common factor or increase equivalent, so you can double or triple, you know, everything. We can write equivalent ratios, and you can write equivalent fractions, okay? How they're different. Now, this is really squishy writing, so you're going to have to kind of hear my words as well. Ratios, you cannot reduce to a whole or a mixed number. We already discussed that and talked about why. With fractions, you can. It says can be reduced to a whole number or a mixed number. Okay. How they're different. Ratios are a comparison. Remember, there are two amounts. A fraction is one amount, like half a cup of sugar, where you might say for 1 cup of sugar, you need 2 cups of butter, or something like this. Here's an interesting part. A fraction can be part of a ratio. What if you were baking and you needed 1/2 cup of sugar to every 1 cup of butter, something like that, okay? The ratio is 1/2 to 1, okay? We're going to talk more about how we deal with that and how we actually make that more simple to understand and find the simplified forms. Sometimes we have to compare decimals, okay? So you have to find out which has a better percentage of things. Which class actually has different rates of girls versus boys in the seats, okay? So one way we can compare decimals, or I'm sorry, compare ratios, is converting both to decimals. Now that's interesting, right? Let's talk about that. Writing a ratio as a decimal. Well, here's another way. I guess they're the same as fractions, because you would divide the, top by the bottom. Here we are again. It's like the math motto for all of 6th grade. Divide the top by the bottom and you'll be fine. For the most part, that works, okay? So if in one class, let me come down to the bottom here. Now, okay, so I made a point. This is a good way to compare 2 or more ratios. And I wrote down the ratios of girls to boys in my 2 largest classes from last year. Okay, so in my 6th grade honors class, I had 7 girls to 10 boys. And in my 7th grade class, I had 9 girls to 6 boys. So which one had the higher rate of girls to boys? Okay, and this blue writing over here says, this stuff here says, convert both to decimals to find the bigger population of girls. So which class had a bigger proportion of girls? Okay, so if I divide the top by the bottom, I get 0.7 for this one, and for this, I get 1.5. Now you might be able to use some logic and reasoning that 7 out of 10, obviously that's less girls than boys, and over here it's 9 to 6, so I have more girls than boys, but sometimes our numbers aren't always going to be that obvious. And so that is the technique you would use, and you can see there are a smaller amount of girls in my 6th grade class than in my 7th grade class. Okay, we're going to skip the flag example here. So let me erase that. Might be a good time to pause and maybe go back and do anything you might need to do. Okay. Let's compare the ratios below and tell whether they're equal or not and why. Let's say I have a ratio of 16 to 3, okay, comparing it to 27 to 5. Now, again, one of the ways we could do this is making it a decimal. So let's start by trying that. 16 divided by 3. Going to give a couple zeros. I know 3s are never going to divide evenly. This will be 5. My leftover is 1. Okay, so that's what we get for this. This as a decimal, oops, and do the other one. Obviously, I'm only going to need a 0 because that is the multiple of 5 rule. It's going to go in here 5 times, a leftover of 2. Ooh, these are pretty close, huh? 5.2. Now you can compare. Now, if this was a ratio of girls to boys in a particular class setting, you can see that it's close, but there is a bigger population, a larger population of girls in the first class. Another way we can do it, like I said before, is using equivalent ratios. So again, they're not fractions. So you could look at this and multiply this one by 3, multiply this by 5. That's a lot of multiplication. So I think I like the other way better for this particular one. But 16 times 5, I believe, is 80. 80 fifteenths. So if I increased the amount of girls and boys by 5 times, that would be, I would have 80 girls and 15 boys. Now, 27 times 3, 81, I believe. No, is it? Let me double check my work. That's 21, 6, 7, yeah, 81 out of 15, okay? So that doesn't really prove my point because 80 is less than 81. Did I do something wrong? 16 times 5, 30. Interesting, because 5.3 is a bigger decimal, so maybe I messed up on my division somehow, but I don't think I did either. Interesting. Okay, well, bonus points if you catch the mistake. How's that? So focus on that. Try it both ways for class. I'll remember to do it in class tomorrow as well. We'll do it both ways. It was 27 to 5, yep, and 16 to 3. That'll be a good challenge question. I would stay figured out, but we got to go. Okay, so I skipped the flag. Okay. Sometime you will see ratios that involve whole numbers and fractions. Now I just did one kind of like that with the cups of sugar, and the example would be 4 to 2/3. This is one way to write it. This is the second way to write it, 4 to 2/3, and as a fraction form, what would that look like? Yeah, that weird totem pole of numbers. 4 to 2/3, and remember the first one goes on top. Now that's not simplified. Okay, so we're going to have to figure out how to make this a simplified fraction. I'm sorry, not a fraction, a decimal. We're going to have to figure out how we are going to solve that problem. I'm actually going to stop here and teach that to you in class when I see you tomorrow. Right now, you just kind of have some basic ideas on how to work with ratios and how to sort of set them apart from fractions, how they're similar to fractions, so you already have some basic sense on how to work with these, okay? Your challenge problem is figuring out why this information, we got some different results here, because this says there's a larger population of girls and this says this one has a larger population of girls. So find my mistake and I will see you tomorrow.